Good morning, students. In this session, we will prove that how Coulomb's law agrees with the Newton's third law of motion. Whether Coulomb's law obeys the Newton's third law of motion or not, that we will prove here. Okay. For that, let us consider 2-point charges Q1 and Q2 located at 2 points in vacuum. In the figure, you can observe here charge Q1 and Q2. Let R1 and R2 be the position vectors. Okay, position vectors of charge Q1 and Q2 respectively with reference to the origin. Okay, these R1 and R2, these two are the position vectors of the charge Q1 and Q2. What do you mean by position vectors? Position vectors are nothing but the vectors which we will use to locate the charges in this three-dimensional coordinate system. ಅಂದರೆ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ಸ್ನ ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ ಅದರ ಹೆಸರೇ ಹೇಳುತ್ತೆ Q1 ಮತ್ತು Q2 ಚಾರ್ಜು ಈ 3-ಡೈಮೆನ್ಷನಲ್ ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮಲ್ಲಿ ಎಲ್ಲಿ ಲೊಕೇಟ್ ಆಗಿದ್ದಾವೆ ಅಂತ ಹೇಳೋಕ್ಕೆ ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ಸ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ R1 ಪೊಸಿಷನ್ ವೆಕ್ಟರು Q1 ಚಾರ್ಜ್ ಎಲ್ಲಿದೆ ಅಂತ ಹೇಳುತ್ತೆ ಆ್ಯಂಡ್ R2 ಪೊಸಿಷನ್ ವೆಕ್ಟರು Q2 ಚಾರ್ಜ್ ಎಲ್ಲಿದೆ ಅಂತ ಹೇಳುತ್ತೆ. ಸೊ ದೀಸ್ ಆರ್ ದಿ ವೆಕ್ಟರ್ಸ್ ವಿಚ್ ವಿಲ್ ಯೂಸ್ ಟು ರೆಪ್ರೆಸೆಂಟ್ ಆರ್ ಟು ಡಿನೋಟ್ ದಿ position of the given charge. We will use position vectors. Clear? Now from triangle law of vector addition, we already have studied about the vector addition and all. From the triangle of vector addition, we can write that vector R21 is equal to vector R2 minus vector R1. Vector R21 is this one. Okay, vector R21 is equal to this vector R2 minus this vector R1. And similarly, if vector R21 is equal to R2 minus R1, then vector R12 is equal to R1 minus R2. That we can write. Now let us move ahead. From the Coulomb's law, force exerted on Q2 by Q1 is given by. Okay. From the Coulomb's law, the force exerted on Q2 by Q1. Okay. ಚಾರ್ಜ್ Q2 ಮೇಲೆ ಚಾರ್ಜ್ Q1 ಫೋರ್ಸ್ ಎಕ್ಸರ್ಟ್ ಮಾಡುತ್ತೆ. ಆ ಫೋರ್ಸ್ ಯಾವುದು ಅಂದರೆ ಫೋರ್ಸ್ F21. ಫೋರ್ಸ್ ಎಕ್ಸರ್ಟೆಡ್ ಆನ್ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ Q2 by Q1. That can be calculated by Coulomb's law. So which is F21 is equal to 1 by 4 pi epsilon naught and product of both the charges Q1 and Q2 by square of the distance between them, which is R12 square. And this is multiplied by R21 cap, unit vector. What do you mean by this unit vector? This unit vector is used to represent the direction of this force F21. This force F21 is having the direction of cap R cap 21. Okay, so this is, you can call it as equation 1. Now force exerted on charge Q1 by Q2, that we can call it as force F12. Force F2 ಕೂಡ ಚಾರ್ಜ್ Q2 ಕೂಡ ಚಾರ್ಜ್ Q1 ಮೇಲೆ ಫೋರ್ಸ್ ಎಕ್ಸರ್ಟ್ ಮಾಡುತ್ತೆ. ದಟ್ ಫೋರ್ಸ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಫೋರ್ಸ್ F12. ಓಕೆ, ದಟ್ ಅಗೇನ್ ವಿ ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಯೂಸಿಂಗ್ Coulomb's law. 1 by 4 pi epsilon naught product of these two charges Q1 Q2 and square of the distance between them, which is R12 square, which is multiplied by R21 cap. R21 cap is nothing but it is a unit vector which is in the direction of this force F21. Clear? Now we can observe this R12 cap can be written as R12 cap can be written as minus of R21 cap, because these R12 cap and R21 cap both are having same magnitude but both are having different direction. ಎರಡು ಈಕ್ವಲ್ ಇದಾವೆ ಬಟ್ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಇದೆ. ಸೊ ದಟ್ಸ್ ವೈ ಕ್ಯಾಪ್ R12 ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್ ಮೈನಸ್ ಆಫ್ R21. ಓಕೆ, ಇದರ ವಿರುದ್ಧ ದಿಕ್ಕಿನಲ್ಲಿ ಇದೆ ಅಂತ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ ಮೈನಸ್ ಸೈನ್. ನಾವು ವಿ ಕ್ಯಾನ್ ಕಂಪೇರ್ ಇಕ್ವೇಷನ್ 1 ಆ್ಯಂಡ್ ಇಕ್ವೇಷನ್ 2 ಈಸಿಲಿ. ಸೊ ಬೈ ಆನ್ ಕಂಪೇರಿಂಗ್ equation 1 and equation 2, you can observe all the terms are same in both the equation except this R21 and R12. Clear? You can observe in this F21 and F12, here it is R21 is positive, here R21 is negative. So that we can easily say that the force F21 is equal to minus of force F12. So what is the meaning of this equation is the force exerted by charge q1 on charge q2 is equal to the force exerted by charge q2 on charge q1. ಎರಡು ಚಾರ್ಜು ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಎಕ್ಸರ್ಟ್ ಮಾಡುವಂಥ ಫೋರ್ಸು ಈಕ್ವಲ್ ಆಗಿದೆ, ಬಟ್ ದೇ ಆರ್ ಇನ್ ಆಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್. ಸೊ ನೌ ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಸೇ ದ್ಯಾಟ್ the forces exerted by two charges on each other are equal and opposite. Therefore, now let us try to understand the difference between charge and mass. So among that, first one, the charge may be positive or negative, whereas mass is always positive. Okay, you can never have a negative mass, whereas you can always have positive or negative charge. Okay, the next one, charge does not vary with the velocity. Charge will never vary with the velocity. As velocity increases and charge will not vary, it will always be constant with the velocity, whereas mass increases with the velocity. How a mass can increase with velocity? This can be proved using Einstein's relativity theory, which is E equal to mc square. The equation says that as the velocity or speed of a body approaches to speed of a light, then its energy increases. When the energy of a given body or mass increases, then its mass also increases. Clear? So that is what the Einstein's relativity theory says. As velocity increases, then the mass of a body also increases. Then third one, charge is conserved, whereas mass is not conserved, because mass can be converted into energy, whereas energy also can be converted into mass. That is why mass is not conserved, whereas charge is conserved. Conserved means you can never destroy or create a charge. You can just transfer charge from one body to another body. So that is what the conservation says. So that is why charge is conserved, whereas mass is not conserved. The next one, charge is quantized, whereas mass is not considered to be quantized. What do you mean by quantized? Quantized means nothing but it is available only in particular values. Okay, the charge can be available in only discrete values, in particular values. You can always say that the smallest entity of a charge as E. Clear? The smallest entity or smallest value of a charge in this universe is E, which is 1.6 into 10 to the power minus 19 Coulomb. Whereas mass can occur in any arbitrary values. There can no fixed value for mass. It can occur in any values. Whereas charge can occur in only fixed values or discrete values, which is E or which is a multiple of E. ಚಾರ್ಜು ಇ ಆದರೂ ಇರುತ್ತೆ ಅಥವಾ ಅದರ ಮಲ್ಟಿಪಲ್ ಆಫ್ ಇ ಆದರೂ ಇರುತ್ತೆ. ಸೊ ನಂಬರ್ ಆಫ್ ಚಾರ್ಜ್ ಆರ್ ದ ಟೋಟಲ್ ಚಾರ್ಜ್ ಆರ್ ನೆಟ್ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ಇ, ಆರ್ ಇಟ್ ಈಸ್ ಅ ಮಲ್ಟಿಪಲ್ ಆಫ್ ಇ ಆರ್ ಇಂಟಿಗ್ರಲ್ ಮಲ್ಟಿಪಲ್ ಆಫ್ ಇ. ಸೊ ದಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಕ್ವಾಂಟೈಸ್ಡ್. ಸೊ ಚಾರ್ಜ್ ಈಸ್ ಕ್ವಾಂಟೈಸ್ಡ್ ವೆರಾಸ್ ಮಾಸ್ ಈಸ್ ನಾಟ್ ಕ್ವಾಂಟೈಸ್ಡ್. ನೆಕ್ಸ್ಟ್ ಒನ್, it plays an important role in electricity. Charge plays an important role in electricity because the charged particle produces electricity, whereas the mass plays an important role in gravitation. Then sixth one, charge does not exist without mass. Charge does not exist without mass, whereas mass can exist without charge. You can easily say this, charge mass illದೆ charge ಇರೋದಿಲ್ಲ, but mass can always occur without a charge. The next one, in SI system it is a derived physical quantity. Charge is or Coulomb is a derived physical quantity, whereas mass is a fundamental physical quantity. Charge is a derived physical quantity, whereas mass is a fundamental physical quantity. Now SI unit of a charge is Coulomb, whereas SI unit of mass is kg. Clear? Then move to next one. Now we will understand the difference between Coulomb force and gravitational force. Coulomb force, it depends on the magnitude of charges. We always know that. Okay, Coulomb's force is nothing but it is related to charges. That is why the Coulomb force depends on the magnitude of charges, whereas gravitational force depends on the magnitude of masses. Clear? It is a magnitude of charges, Coulomb force. Gravitational force is the magnitude of masses. Then Coulomb force may be attractive or repulsive. Coulomb force may be attractive or repulsive, whereas gravitational force is always attractive. Clear? The next one, net force may be zero. The net electric force or Coulomb force may be zero, whereas gravitational force can never be zero. Why? Because you can have, or we can have, positive or negative or attractive or repulsive Coulomb force. That is why the net force can be zero, whereas gravitational force is always attractive, no? So that is why it can never be zero. Now, Coulomb force depends on the nature of the medium between the charges. Coulomb force depends on the nature of the medium between the charges, whereas it is independent of the medium between the charges. Now next one, Coulomb force is much stronger than gravitational force. It is much stronger than gravitational force, whereas it is the weakest force available in the nature. Which one? Gravitational force is the weakest force in nature. Now we will try to find out the meaning of superposition principle of forces, and we will apply this superposition principle of forces to find the force on a point charge due to system of n point charges. Okay, first let us understand what is the meaning of superposition principle of forces. The superposition principle of forces says that the resultant force on any charge due to a number of charges is the vector sum of all the forces due to all other charges. Okay, the meaning of this statement is that, see, you can observe the figure here. Let us consider a point charge q1. Okay, and around this point charge q1 there are two more charges, which is q2 and q3. Now if you want to find out the net force or resultant force which is acting on this point q1 due to the point charges q2 and q3, okay, the net force due to q2 and q3 on charge q1 is equal to the vector sum of these two forces on the charge q1. Okay, overall meaning is superposition principle though. ಓಕೆ, ಇಲ್ಲಿ ಮೂರು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಇದ್ದಾವೆ, q1, q2 ಆ್ಯಂಡ್ q3. ಈಗ ನಾವೇನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಚಾರ್ಜ್ q1 ಮೇಲೆ q2 ಮತ್ತು q3 ಎಷ್ಟು ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ ಮಾಡ್ತಿದ್ದೇವೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು ಅಂತ ಅಂದ್ಕೊಳ್ರಿ. ಕ್ಲಿಯರ್? ಸೊ q2 ಮೇಲೆ ಟೋಟಲ್ ಫೋರ್ಸು q1 ಮೇಲೆ ಆಗ್ತಿರುವಂಥ ಫೋರ್ಸ್ ಎಷ್ಟಾಗಿರುತ್ತೆ ಅಂದರೆ q2 ಆ್ಯಂಡ್ q3 ಇವೆರಡೂ ಚಾರ್ಜು ಎಷ್ಟು ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ ಮಾಡುತ್ತಿರುತ್ತಲ್ಲ ಅದೆರಡರ ಸಮೇಷನ್ನು q1 ಮೇಲೆ ಆ್ಯಕ್ಟ್ ಆಗ್ತಿರುತ್ತೆ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಸೂಪರ್ಪೊಸಿಷನ್ ಪ್ರಿನ್ಸಿಪಲ್. ಸೊ ಹೌ ಟು ಫೈಂಡ್ ಔಟ್ ದಿ ಟೋಟಲ್ ಫೋರ್ಸ್ ವಿಚ್ ಈಸ್ ಆ್ಯಕ್ಟಿಂಗ್ ಆನ್ charge particle q1 is the vector sum of force q2 and force q3. So this is what the superposition principle. Now to prove that, let us consider a system of n point charges q1, q2 and q3 up to n. So in this figure, just for our consideration, for simplicity, I have just considered 2 point charges around the point charge q1. Total we have 3 point charges q1, q2 and q3. Clear? Now the force on q1 due to q2. The force on q1, charge particle q1 due to the charge particle q2 is nothing but this much, which is the electrostatic force between the force charge q1 and charge q2, which is equal to F12. The force acting on charge particle q1 due to charge particle q2, which is equal to F12 is equal to 1 by 4 pi epsilon naught, then product of these two charges q1 and q2 by square of the distance between them r12, let it be, then multiplied by the unit vector r12. This unit vector r12 represents the direction of the force which is along the F12. Clear? That is what this unit vector says. Then similarly, the force on q1 due to q3, this is force on q1 due to q2. Now this is force on q1 due to this charge particle q3, then that is equal to 1 by 4 pi epsilon naught product of these two charge particle q1 and q3 and divided by square of the distance between them, which is r13 square multiplied by unit vector r13. This r13 is nothing but unit vector which says or which represents the direction of the force F13. Clear? Now similarly, if you write this similar equation for nth charge, if there are n number of charge particle around this q1, then similarly for all the charge particle we can write like this: f12, f13, f14, f15, f16 up to f1n. Whatever the number of the particles may be, you can consider. So like that, for nth particle f1n equal to 1 by 4 pi epsilon naught q1 into qn by r1n square multiplied by unit vector. So similarly we can write it for many number of charge particles around the charge particle q1. Now from the superposition principle ಏನು ಹೇಳುತ್ತೆ ಅಂದರೆ resultant force on the charge q1 which is vector F is equal to total force acting on the charge particle q1 is equal to force due to q2, force due to q3, force due to q4, like that. But in this diagram I have considered only two charge particles, which is q2 and q3. Now what I need to calculate is the total force acting on the charge particle q1 is equal to the force acting on charge particle q1 by q2 and also force acting by the charge particle q3 on q1. So if you add these two, then total net force acting on charge particle q1 due to the other two particles q1 and q3, which is equal to this much. Okay, so like that. So if you simplify this equation, if you put it in the summation form, and it becomes like this. So this equation is nothing but what this equation says, that this electrostatic force agrees with the superposition principle. So that means that we can apply superposition principle while calculating the total effect or total force or net force acting on a given charge particle due to the other charge particle which are surrounding the given charge particle. Clear? Okay, now in order to move ahead into the topic, we need to define another important parameter regarding electric charge is electric field. Okay, this term is very important in coming session. Okay, so let us define what is the meaning of electric field. Let us understand what is electric field. Electric field is nothing but it is the region in which the charged particles experiences electrostatic force. Clear? Electric field is nothing but it is the region in which any charged particles experiences electrostatic force. Electric field is nothing but generally it is an area around the any given charged particle or any given charged body. ಯಾವುದಾದ್ರೂ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ತೊಗೊಳ್ರಿ, ಅದು ಸುತ್ತಲೂ ಇರುವಂಥ ಪ್ರದೇಶಕ್ಕೆ ಅಥವಾ ಅದು ಸುತ್ತಲೂ ಇರುವಂಥ ಏರಿಯಾಗೆ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಕರಿತೀವಿ. ಯಾವುದೋ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಸುತ್ತಲೂ ಇರುವಂಥ ಏರಿಯಾದಲ್ಲಿ ನೀವು ಯಾವುದೋ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ನ ಅದರಲ್ಲಿ ಇಟ್ಟರೆ both will interact, both electric field as well as the charge that you have placed, both will interact. ಯಾವುದೋ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಸುತ್ತಲೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ, ಹೌದಾ? ಆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಲ್ಲಿ ನೀವು ಇನ್ಯಾವುದೋ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಇಟ್ಟರೆ ಅವೆರಡು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡು ಮತ್ತು ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ಲು ಎರಡು ಒಂದ್ರ ಮೇಲೆ ಒಂದು ಫೋರ್ಸ್ ಆ್ಯಕ್ಟ್ ಮಾಡ್ತವೆ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಯಾವುದೋ ಒಂದು ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಆ ಚಾರ್ಜ್ ಬಾಡಿ ಸುತ್ತಲೂ ಒಂದು ಏರಿಯಾ ಇರುತ್ತೆ, ಆ ಏರಿಯಾಗೆ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ ಅಂದರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ದಿಸ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಸಿಂಪಲ್ ಮೀನಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. Now we need to define what is the intensity or what is the strength of the given electric field. ಆ ಫೀಲ್ಡಲ್ಲಿ ಅಥವಾ ಏರಿಯಾ ಅರೌಂಡ್ ಗಿವನ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಸುತ್ತಲೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ವಿ. ಆ ಫೀಲ್ಡ್ ಎಷ್ಟು ಸ್ಟ್ರಾಂಗ್ ಆಗಿರುತ್ತೆ ಅಥವಾ ವಾಟ್ ಈಸ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದಟ್ ಫೀಲ್ಡ್ ಆರ್ ವಾಟ್ ಈಸ್ ದ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ದಟ್ ಫೀಲ್ಡ್, ದಟ್ ವಿ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಫಾರ್ ಅ ವೇರಿಯಸ್ ರೀಸನ್ ಆರ್ ಫಾರ್ ಮೆನಿ ಪ್ರಾಬ್ಲಮ್ಸ್, ಪ್ರಾಕ್ಟಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್. ಇನ್ ಆರ್ಡರ್ ಟು ಸಾಲ್ವ್ ವಿ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ವಾಟ್ ಈಸ್ ದಿ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಗಿವನ್ ಫೀಲ್ಡ್. ಆ ಏರಿಯಾದಲ್ಲಿ ಎಷ್ಟು ಸ್ಟ್ರೆಂತ್ ಇದೆ ಆರ್ ವಾಟ್ ಈಸ್ ದ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. ಸೊ ದಟ್ ಇಂಟೆನ್ಸಿಟಿ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಆರ್ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕ್ಯಾನ್ ಬಿ ಡಿಫೈನ್ಡ್ ಆಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಆರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಂಟೆನ್ಸಿಟಿ ಎಟ್ ಅ ಪಾಯಿಂಟ್ ಇನ್ an electric field is the force experienced by the unit positive charge placed at that point. Okay, electric intensity or electric field strength is nothing but it is the force experienced by the any unit positive charge placed at that particular point. So if you put any unit positive charge at a particular electric field, then it experiences some force. Clear? The force experienced by the unit positive charge at a particular electric field is called intensity of that electric field. Okay, ಯಾವುದೋ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡಲ್ಲಿ ನೀವು ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಇಟ್ರಿ ಅಂತ ಅಂದ್ಕೊಳ್ರಿ. ಆ ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಮೇಲೆ ಫೀಲ್ಡು ಫೋರ್ಸನ್ನು ಆ್ಯಕ್ಟ್ ಮಾಡುತ್ತೆ. ಆ ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಮೇಲೆ ಆ್ಯಕ್ಟ್ ಆಗುವಂಥ ಫೋರ್ಸ್ ಆ ಫೀಲ್ಡ್ದು ಇಂಟೆನ್ಸಿಟಿ ಆಗಿರುತ್ತೆ. ಕ್ಲಿಯರ್? ಸೊ ದಟ್ ಈಸ್ ದಿ ನಥಿಂಗ್ ಬಟ್ meaning of electric strength or electric field intensity. Then the SI unit of electric field is nothing but Newton per Coulomb, or also we can express it as volt per meter. Clear? Then this electric intensity E is equal to force acting per unit positive charge. This electric field intensity is vector quantity. That is why I have used vector symbol here. Vector E is equal to vector force F by Q naught. So electric field strength or electric field intensity is nothing but force experienced by unit positive charge, okay, which is kept at that particular electric field. So this is what the concept of electric field and electric field intensity or strength. Now let us move ahead. Just now we have defined the term electric field intensity. Okay, now we will understand, or we will try to find out electric field strength or electric field intensity due to an isolated point charge. Now we need to find out what is the strength of a point, what is the field strength, or what is the intensity of electric field produced by isolated point charge. ಯಾವುದೋ ಒಂದು isolated unit point charge ಅಂತ ಅಂದ್ಕೊಳ್ರಿ. Then how much intensity that a unit isolated point charge can generate or can create, that we need to find out here. For that, consider a point charge Q. You can observe the diagram. Okay, consider a point charge Q placed at point A as shown in the figure. Let us find the electric field E at a point P at a distance r from charge Q. Imagine a positive point charge Q naught at P. The charge Q produces electric field E at P. Okay, so to calculate the field intensity produced by the isolated point charge around the charge Q, what I have considered is, here I have considered one point charge Q. ಈ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಕ್ಯೂ ಎಷ್ಟು ಇಂಟೆನ್ಸಿಟಿನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಿದೆ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಅರೌಂಡ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಕ್ಯೂ ದೇರ್ ವಿಲ್ ಬಿ ಎ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್. ಕ್ಲಿಯರ್? ಈ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಕ್ಯೂ ಸುತ್ತಲೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಈ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಕ್ಯೂ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಿದೆ, ಆರ್ ವಾಟ್ ಈಸ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವಿಚ್ ಈಸ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಬೈ ಕ್ಯೂ, ದಟ್ ವಿ ನೀಡ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್. ಕ್ಲಿಯರ್? ಫಾರ್ ದಟ್ ವಾಟ್ ಐ ಹ್ಯಾವ್ ಕನ್ಸಿಡರ್ಡ್ ಈಸ್, ಐ ಹ್ಯಾವ್ ಕನ್ಸಿಡರ್ಡ್ ಒನ್ ಪಾಸಿಟಿವ್ ಕ್ಯೂ ಚಾರ್ಜ್. ಓಕೆ, ಕ್ಯೂ ವಿಚ್ ಈಸ್ ಎಟ್ ಎ. ಆಮೇಲೆ ನಾನೇನು ಮಾಡ್ತೀನಿ ಅಂದರೆ, ಐ ಹ್ಯಾವ್ ಕನ್ಸಿಡರ್ಡ್ ಅ ಪಾಯಿಂಟ್ ಪಿ ಹಿಯರ್, ವಿಚ್ ಈ ದಿಸ್ ಪಾಯಿಂಟ್ ಪಿ ಈಸ್ ದಿ ಡಿಸ್ಟೆನ್ಸ್ ಆರ್ ಫ್ರಮ್ ಪಾಯಿಂಟ್ ಕ್ಯೂ. ಈ ಪಾಯಿಂಟ್ ಪಿ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಲ್ಲ, ಈ ಪಾಯಿಂಟ್ ಕ್ಯೂಗಿಂತ ಆರ್ ಡಿಸ್ಟೆನ್ಸಲ್ಲಿ ದೂರದಲ್ಲಿದೆ. ಕ್ಲಿಯರ್? ನಾವು ಎಟ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಐ ಹ್ಯಾವ್ ಪ್ಲೇಸ್ಡ್ ಒನ್ ಮೋರ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಕ್ಯೂ ನಾಟ್. ಇನ್ನೊಂದು ಚಾರ್ಜ್ನ ಪಾಯಿಂಟ್ ಪಿಯಲ್ಲಿ ಇಡ್ತೀನಿ. ಎಲ್ಲಿ? ಈ ಪಾಯಿಂಟ್ ಪಿ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ? 6 ಮೀಟ್ರ್ ದೂರದಲ್ಲಿದೆ ಚಾರ್ಜ್ ಕ್ಯೂಗಿಂತ. ಕ್ಲಿಯರ್? ನಾವು this is what the procedure that I have done. Now the force applied by Q on Q naught is given by, clear? We have one positive Q charge and we are going to calculate the intensity produced by this isolated charge Q. For that I have considered another test charge which I have kept at a distance of r from the Q. Now the force applied by Q on Q naught is given by, if you keep one charge beside another charge, we already know that it experiences, both will exert a force on each other. Clear? Now the force applied on Q, this charge particle Q on the charge particle Q naught test charge is given by, again Coulomb's law of electrostatic, F which is equal to 1 by 4 pi epsilon naught, then product of these two charges Q into Q naught by square of the distance between them, which is r square. Clear? Now according to definition, just I will rearrange here, just you According to definition, this equation I got it from the Coulomb's law. The force exerted by charge q on this test charge q naught. Now, according to definition of electric field which is equal to F by q naught. E equal to F by q naught is nothing but it is the definition for field intensity, that is force experienced. Electric field strength is nothing but force experienced by unit positive charge at that particular field is nothing but the electric field intensity. Clear? Now, which is equal to 1 by 4 pi epsilon naught into q by r square. Okay students, till now we have discussed about what is the definition of electric intensity, what do we mean by electric field, each and everything we have discussed. In today's class, let us have a glance at what is the meaning of uniform electric field. Okay, so the name itself will suggest us that something is uniform here. Okay, if you want to call any electric field as uniform electric field, then uniform electric field is the electric field in which unit positive charge experiences the same force at all the points. Okay, we already defined the definition for electric intensity. Electric intensity is nothing but it is the force experienced by a unit positive charge at a given point. Okay, if the unit positive charge experiences the same force at all the points, then that field or that electric field we can call it as uniform electric field, because the force or electrostatic force of a given field is constant on a unit positive charge at all the points. Clear? So that is the reason why we can call it as this given electric field as a uniform electric field. Clear? Now, the non-uniform electric field, it is obviously the reverse of this uniform electric field. Here, at all the positions, an electric force which is experienced by the positive charge is not constant. Okay, at different places in a given field, you will get a different force. We will get a different force in the sense the positive charge will experience different force at a different points. So that is why it is non-uniform electric field. In the figure you can observe here, okay, some of the diagrams for non-uniform electric field, okay, and uniform electric field. Okay, this field is an example for uniform electric field, because at all the points unit positive charge will experience the same intensity. Now this is the example for non-uniform electric fields. Okay, this is the non-uniform electric field. This is also example for non-uniform electric field. Okay, this is the concept of uniform electric field as well as non-uniform electric field. So now let us have a glance at what is the definition for source charge. Source charge is the charge which produces the electric field that we define. Okay, source charge is nothing but it is the source from which the electric field is arising, or it is the source charge is nothing but it is the point from where this electric field is originated. Okay, that is what we will call it as source charge. So the source charge can be a single charge, or it may be a group of charges, or any continuous distribution of charge. Okay, this source charge doesn't mean that it should be a single point or it should be a single charge. It may be a group of charges, or it may be a system of charges, or it may be any continuous distribution of charges. So source charge, the overall meaning of source charge is nothing but it is the space, or it is a point from which this electric field is arising. So that we can consider it as a source charge. Now let us state the superposition principle of electric field and apply this law to find electric field due to system of n point charges. Superposition principle of electric field is nothing but if you want to calculate any electric field or electric intensity at a given point, then the total electric field at a given point is equal to the electric fields produced by the number of charges which are surrounding the given point. So that is nothing but the superposition principle of electric field. Superposition of principle of electric field andre, if for example illೊಂದು point consider ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ point P, you can observe in the diagram here. Okay, if you want to calculate total electric field at this point, Okay, what we have to do is we have two charges here. Okay, q1 ಒಂದು ಚಾರ್ಜ್ ಇದೆ, q2 ಚಾರ್ಜ್ ಇದೆ ಟೋಟಲ್. ಇವು ಎರಡು ಚಾರ್ಜ್ ಕೂಡ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಿದ್ದಾವೆ ಎಲ್ಲಿ ಗಿವನ್ ಪಾಯಿಂಟ್ ಪಿ ನಲ್ಲಿ. ಸೊ ಟೋಟಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಆರ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಟ್ ಅ ಗಿವನ್ ಪಾಯಿಂಟ್ ಪಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಸಮ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಬೈ ಚಾರ್ಜ್ q1 ಆ್ಯಂಡ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ಡ್ ಬೈ ದಿ ಚಾರ್ಜ್ q2. ಇವೆರಡೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿನ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಎಷ್ಟಿರುತ್ತೋ ಅಷ್ಟು ಇಂಟೆನ್ಸಿಟಿ ಪಾಯಿಂಟ್ ಪಿ ನಲ್ಲಿರುತ್ತೆ. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ದಿ ಮೀನಿಂಗ್ ಆಫ್ ಸೂಪರ್ಪೊಸಿಷನ್ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್. So for that, so to prove or to apply this superposition principle of electric field to given example here, let us consider 2 point charges q1 q2. Any number of charges you can consider here, but just for the simplicity I have considered 2 electric charges. Let us consider 2 electric charges q1 and q2 be the point charges at a distance of r1 and r2 from the point P. Okay, this is the point P what we have considered. Clear? At this point we are going to calculate the total intensity at a given point P. So let us move ahead. Electric field at point P due to charge q1 is given by this formula. Already we have discussed about this formula and already we have derived also. Okay, electric field at a point P due to this electric charge q1 can be calculated by E equal to 1 by 4 pi epsilon naught q1 by r1 square multiplied by the r1 cap unit vector. Unit vector r1 cap is nothing but it gives the direction of this electric field E. Clear? So this is the electric field E in this direction. Now electric field at point P due to charge q. Now from this charge, so E equal to 1 by 4 pi epsilon naught q2 by r2 square into r2. So E2 is in this direction. Clear? ಇಲ್ಲಿ q1 ಮತ್ತು q2 ಎರಡೂ ಕೂಡ ಇಂಟೆನ್ಸಿಟಿನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಿದ್ದಾವೆ ಎಟ್ ಗಿವನ್ ಪಾಯಿಂಟ್ ಬಿ ನಲ್ಲಿ. ಅದನ್ನು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಕ್ಲಿಯರ್? ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಎಟ್ ಪಾಯಿಂಟ್ ಪಿ ಡ್ಯೂ ಟು ದ ಚಾರ್ಜ್ q1 is this much. Clear? Now electric field intensity at point P due to charge q2 is this much. Clear? Similarly, if you have another charge, for simplicity I have considered only 2 charges q1 and q2. In case while solving any other problems, if you have any one more charge or if you have n number of charges, you may have thousands of charges around this point P. So like that, similarly for nth charge electric field at point P due to a nth charge is given by this formula. Clear? Now from the superposition principle is nothing but the total electric field at a point P is equal to the electric field produced by the charges which are around this point. At this instant I have considered only 2 charges. ಎರಡೇ ಚಾರ್ಜ್ ಸುತ್ತಲೂ, ಅದಕ್ಕೆ ಎರಡನ್ನು ಮಾತ್ರ ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತೀನಿ. ಕ್ಲಿಯರ್? ಸೊ ಟೋಟಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಟ್ ಪಾಯಿಂಟ್ ಪಿ ಈಸ್ ಈಕ್ವಲ್ ಟು E1 ಪ್ಲಸ್ E2 ಪ್ಲಸ್ E3 ಪ್ಲಸ್ ಅಪ್ ಟು En. ಎಷ್ಟು ಚಾರ್ಜ್ ಇರ್ತವೆ ಅಷ್ಟೆಲ್ಲವನ್ನು ನಾವು ಆ್ಯಡ್ ಮಾಡಬೇಕು. But in this condition I have only 2 charges q1 and q2. Let us add this equation E1 and E2 up to En. So if you get the summation of it, so this formula will give us the total intensity of electric field at a given point P. So this is what the superposition principle of electric field. Okay, let us move ahead. Now what is the physical significance of electric field? What exactly it says? Physical significance means what exactly the value of electric field says. So that is what the physical significance of electric field. What we can understand by the value of electric field, given electric field. Electric field E at any point around a charge or a system of charges is used to calculate the, I repeat, electric field E at any point around a charge or it may be a system of charges is used to calculate the force F experienced by unit positive test charge q0 at that given point. Okay, ಇದು